In this video, we're going to go over the intermediate value theorem. Let's start with the notations and their meanings. These are all the notations of the intermediate value theorem. The first one is 3 dots in the shape of a triangle. The second one is 2 dots above each other and below each other. The third one is a backwards E. The fourth one is an upside down A. And the fifth one is a C with a line in the middle. The first one means therefore, the second one means such that, the third one means there exists, the fourth one means for all, and the fifth one means in. These are important to decoding what the intermediate value theorem actually means. This is the intermediate value theorem, or at least the exact writing. Now let's figure out how to decode this and what it actually means. So the intermediate value theorem is if f of x is continuous on interval a to b, for all m between f of a and f of b, there exists at least one c in interval a to b such that f of c is equal to m. Now that's really confusing in my opinion, so I think we should define it. Here I've circled all of the actual intermediate value notations in red, and I've circled other definitions we should define so that way we can better understand the intermediate value theorem in green. So what I've done is I've taken every circle I've made and rewritten the whole intermediate value theorem in a much more easy to understand way. If something was circled in green, it is now written in green, and if something was circled in red, it's written in red below. So what the intermediate value theorem really is that in a very simple stance, it's that if you have a function, let's say function of y equals x, and let's just say between the interval, meaning between these two x points, -5 and 5, the y values are -5 and 5. Between -5 and 5, the y values, all of those y values, -4, -1, 2, 3, all of those actually exist. That's what the intermediate value theorem really is. So on screen, of course, I have the intermediate value theorem in its original writing with circles to match the below writing, which is a translated version. And then I also have just spoken about the actual simplicity of what the intermediate value theorem really is. Now let's solve this problem. The first step is to always define the function. So in this case, that is fx is equal to 2x plus 7. The second step is to identify if the function is continuous or not. If the function is not continuous, then you just write f is not continuous or fx is not continuous and end the problem. But otherwise, you would just write fx is continuous or f is continuous and continue with your problem. Different teachers teach this step a little differently. So I like to write fx, but some teachers prefer that you write f. The third step is always finding 2 points with the y value that you're trying to prove the IVT for in the middle. In this case, they have done it for us because this is a very basic problem, but sometimes you have to find these points yourself. This step is also very important because without this step, IVT cannot be applied at all because you do not know which 2 points you're trying to use to prove that the function includes this y value. So what we're doing in our last step here is using the IVT notation to write out the proof that we've just proven that 11 is in the interval 9 to 15. Therefore, there exists a value of c in the interval 1 to 4 such that f of c is equal to 11. So that's the intermediate value theorem by ilikemaths.com. Please subscribe to our channel and leave a like if you enjoyed this video and if it helped you learn the intermediate value theorem, and drop any questions that you have down below in the comments.